In this session, I'm going to build a random forest classification model. So for that, first let's import basic libraries that we are going to use. So import libraries. So we import the required libraries first. So we need, so let's import NumPy, Pandas, Matplotlib, as well as Seaborn. So we know NumPy is for array-related operations, and Pandas is for working with data frames, and matplotlib.pyplot. Matplotlib library is used for data visualization, and Seaborn is built on top of matplotlib. So whatever operations cannot be performed on matplotlib can be performed using Seaborn library. So it's higher level data visualization. So so we need from sklearn dot metrics. Let's import. So what all we need? So we'll be finding the ROC curve. So we'll draw ROC curve and area under the curve we want. So we'll give it area under curve. So also from sklearn dot metrics, let's import classification report, confusion matrix as well. Confusion matrix as well as classification report. So now from sklearn.model selection, let's import tenta split. So we have imported tenta split, and also we will import kfold. Kfold is for cross validation. So it is also in sklearn.model selection package. So let's import kfold. Kfold is for cross validation. Also, we need to find out cross validation score. So let's cross val score. So also from model selection, model selection package, we need to import grid search CV. So what does grid search CV does is that it will select the best more parameters. So it's like a model selection package which selects the best parameters for the for the set of values that you have passed for the parameters. Okay, so it is selects the best parametric values. So let's import research CV as well. So from sklearn.model selection, let's pass over here itself research CV. Okay, and also so we have imported these model selection packages. So we know that grid search CV I have already discussed. This is a model selection package. And what it does is that it will select the best parameter values from the given set of values by the user. Okay. So whatever list of values that you have passed, so it will select the best values from a list of values that you have passed so that your model will give high accuracy. Also, we need from sklearn dot tree. So sorry, dot ensemble. So sklearn dot ensemble. So ensemble random forest uses ensemble model. So we import from sklearn dot ensemble. We import random forest classifier. Okay. Let's run these things. So for now, we have imported these many libraries. So if we require some other libraries as well, some other functions that we need, so then we will import other libraries as well. So for now, it's fine. So let's run this code. Okay. So no errors. So what we'll do, so first let's see the data set that we have. So what's the data set? Predictive data. Okay. So we have this data set. So we'll import this data set. So here we have to find out the diagnosis. So let me first import the data set. So let's create data frame. So data frame underscore breast cancer. So here we are trying to find the kind of breast cancer that the person is having. Okay. So with pd.read underscore csv. So let's pass the path, file path. Okay. So we have our data frame. So we have created our data frame underscore breast cancer dot head we will say. Okay. So first before checking, so let's check the head. Okay. So these are the columns that we have. And so we have ID, diagnosis, ID mean, texture mean, perimeter, and so on. Okay. So these many columns that we have, these are the features that we have. So now what we will do is, so we have a data frame. So we have to see the columns that are present in a data frame. So data frame underscore breast cancer dot columns columns. You see these are the columns that we have. Okay. So what? So let's take these columns and sorry, let's copy these columns first. Copy and let's assign to names variable. Just for reference, I'm doing this. These are the columns that we have. And so here we have a data frame where all of the values are numeric except this diagnosis. Okay. So diagnosis is a categorical variable. So, we have to predict the diagnosis, the kind of diagnosis from the given data or the given features that we have. So we have so many features over here in this data set. So, so M represent malign, malignant, and let me show you the tail as well, so you understand. So tail. So B represent benign. Okay. So there are two types of diagnosis, malignant and benign. Benign. So let's pass it into dx variable. Okay. It's called malignant benign, BNIGN, and malignant. These are the two kind of diagnoses that we have for breast cancer. So now what we'll do is that, so we have our ID column and ID is supposed to be unique. So, so we have to make sure that ID is unique, right? So what we can do is, so let's set this ID as our index, okay? So let's do that. So df underscore breast cancer dot set index. Okay, let's see if there is a set index function. Set index, set index of, let's see the parameters, set index of ID. So key here is we want to set index label or ID. So you have to pass ID. as our index. Okay, so let's pass id as our index. Then we want this operation to be performed in the correct data frame itself. So we'll pass in place is equal to true. Okay, so let's see that. So df underscore breast cancer. So before moving further, so we also need to do one thing. So we know that this diagnosis is a categorical variable. So we have categories of values, the category of classes. So we have malignant and benign. So what we can do is, so we will map or we will do the encoding. Okay, so let's do encoding. So we can do label encoding and one hot encoding. So problem with label encoding, one hot encoding is that it will create two columns. Okay, diagnosis M and diagnosis B it will create. So instead of creating two columns, since we have only two classes, so what we can do is that, so we will use map function. So let's map uh, malignant as M as 1 and benign B as 0. Okay, we can do that. Or also we can do label encoder. So from sklearn pre-processing, import label encoder, and you can do the instantiate label encoder part, and then you can define diagnosis as your categorical. So you can make diagnosis take numerical values where it will do the encoding part does internally for malignant and benign. So let's do the mapping part first, okay? Instead of going with encoding, let's do mapping. So when you have, let me show you that PF breast cancer. So we have a diagnosis. So we have a diagnosis column. So where is our diagnosis? So here diagnosis. So what we have to do for this diagnosis, so we have to pass diagnosis. So we have to instantiate it. So we have to change this diagnosis into a categorical classes into numerical one. So df underscore breast cancer of diagnosis is equal to, so df breast cancer of diagnosis dot map. So we are using map function. Okay, we are using map where m represents, so m map it to 1 and wherever b is there, map it to 0. Okay, so let's run this code. Yeah. So now let's see our current data frame for breast cancer. Okay, so let's see the head part only. So we know that we have 32 columns over here. Okay, from here till here we have 32 columns, and so we have made ID as our index, which is unique, and we have also made diagnosis malignant as 1 and benign as 0. So if you want to see, so let me show you in the tail part, we have benign present in the last row. So let me pass tail. So you could see that last value is benign and other value is malignant over here. So now what we will do is that now let's check the missing values, okay? And wherever missing values are there, let's drop those missing values. So here map function we have used, so we haven't used label encoding over here. Label encoding is can be used using sklearn pre-processing. We can do label encoder and import label encoder, and then we can do encoding part for diagnosis feature or column. But we haven't used label encoding. Instead, we can use map function. There are like 2, 3 categorical classes you have. If you have three classes, four classes, then you can just go on and use map function. Okay. So now let's see the missing values and just drop this out. So missing values. So check for missing values. So let's check for missing values. So we have our data frame. So data frame underscore underscore dot is null dot sum. Okay, so we have no missing values in any columns that we have over here. So we can move with the further operation. Um, no missing values are present. So now you could see that. So we have these many columns, right? These many features we have. Let's take it. Okay, it's fine right now. So let's check for dimension. Okay, dimensions of the data frame. So data frame. So best cancer dot shape. So we have 569 rows and 32 columns or 32 features we have. And also data types of columns if you want to see. So df underscore best answer dot d types. So this will give the data types. So all are almost followed except the predict data boolean and diagnosis integer. Okay. Okay, fine. So let's move to the next part. So let's describe. Let's do the describe function. So we can get the 5 point summary as well as count mean and standard deviation for our numerical data set. So almost all the columns that we have are numeric now since we have made diagnosis also numeric. So only one column if it is present that is categorical, that is only predict data. Okay. So predict data is also a categorical value here. So let's not bother about predict data for now. So if you wanted that to convert predict data as well as to zeros and one, we could do. So now let's not bother about it. But I would suggest you to convert here only. So we have our predict data as well, Boolean, right? So what to do? df underscore best cancer of predict underscore data is equal to df best cancer of predict data. Let's do the mapping for this version as well. Map of true is 1, whereas false is 0. So now let's run this code again. So now let's see. Oh, okay. So we have run this code again. So let me run from here onwards. Okay. So now you check. Now it's fine. Okay. So diagnosis is also numerical and predict data. So what's the problem with predict data? There are null values that are present. Let me check. Let me run this code again. So there is some problem with the predict data part. So true is mapped to 1 and false is mapped to 0. Okay. There is some kind of mistake. Let's not bother for now. Let's move for now. Okay. So let's look at it for later. So we have these many data types like we have integer, float, and bool. Almost all the values are in float. Let's perform describe function on our data that we have. So we have already done our what? So no, we have to do right. Okay. Okay, so let's perform describe function on this. So df underscore best cancer dot describe. This will give the 5 point summary, as well as including the mean and standard deviation. So we have got values for all of the features that we have. So we haven't got for predict data because it's not numerical, it's a Boolean value. So because of that, we haven't got. So now what we have to do is that now let's split the data into train and test. Okay. So let's split the data into train and test. And for now, what other thing we can do is that let's drop this column. Okay. Let's just drop this column from our data set. Is it required? Let's see actually. It's not required for now. So now let's split the data into train test. Split data to train and test. So what we have to do is that, so we will call a variable name called feature space, and we have a best answer data frame. So what we have to do is that let's access all the rows and only those which is not diagnosis. Let's drop. What we can do is that let's drop some columns first. So we will say data frame breast cancer dot columns is not equal to mm, let's say diagnosis. Let's say that is our predictor variable. So diagnosis, diagnosis. Okay. Okay. We have got our diagnosis variable. So let's do one thing over here. So, so this predicted data for now, do we have to drop this down? I'm not sure. So let's drop this predicted data for now. Df dot drop of predicted data, predict data. Okay, let's cancel. Okay, so some error has occurred. Drop. So the error we have not found in axis. Data dot drop. So let's see what we can pass over here. Labels equal to predict underscore data. I hope it's correct. Let's giving me an error. So let's not worry about this for now. Let's delete this. So let's run the code, all the code again. Okay, so column not equal to diagnosis, comma, predict data. Let me check if this works now. So yes, I still got an error. So what I can do is, mm, let's remove this. Let's run this code now. Okay, still I got error. What's the problem? Dot dialog. So we have to pass this dot ILOC. Okay, so now it's fine. Can I pass predict data over here? Let me check. No, it's not possible. Control Z. Okay, so I've done that. Feature space. Let's run this and check. Space. So we don't have. Okay, now what I'll do is that I will also drop column called. But so what I have done now is that I just don't want to consider this predict data for now. So that's why what I have done. So we have a feature called predict data over here. So this predict data and diagnosis are almost same. So wherever a malignant is there, we have predict data as true, and wherever benign is there, we have predicted false. For that reason, I'm not considering the predict data for now because I'm doing the mapping function. I will be working as the dependent variable will be this thing for me. Now, what will be the dependent variable for me over here? The diagnosis. Diagnosis will be used for prediction. So one is true, zero is false, like that. So for that reason, what I'm doing is that I'm deleting this column, predict data column over here. So let me delete that. So now you can see that we don't have a predict data column over here. Okay. So now let's run the code over here. This run code. So now we don't have predict data. So over here. So I don't want for now. Okay. So we are taking this as a this is the diagnosis as a dependent one. Okay. So let's run this code again. So we have to do mapping. So this is not required. So we have done the mapping here, and we have taken the tail to check for missing values done, data types is done. So now we have 31 columns, and we don't have a Boolean value for predict data that we had. So now let's do the describe. So now our data set is ready. So what I have done is here is that, so I have considered the independent variables in the feature space. Okay. So I have made sure that we don't have a column diagnosis. So which is our dependent variable. So in another case, I will take feature class. So in feature class, I'm going to pass a data frame dot ILOC of I want all the rows, comma, I only want columns is equal to breast cancer diagnosis. Okay, so the columns is equal to diagnosis. So I'm going taking the only column which is our dependent one here. So we have our feature space and feature class for now. So now what we can do now is that let's do the splitting. Okay, so we have our independent variable feature space and dependent variable feature class. So now let's do the splitting. Okay, split the data into train and test. So let's call it as training set x x in x test or x test will be test set Y train Y set. So class set, comma test class set. So we have X train, Y train. So X train is train set and Y train is a class set. X test is test set, and Y test is test class set. Okay. So now let's do the splitting. Train test split of. So we have to pass X. X is the feature space, comma Y is our feature class, comma X train, comma X, comma Y, comma trace. Test size we will pass. Test size is equal to 0.2, 20% of the data we are considering for testing. And we are fixing this random state as some value. Let's fix this random state. So when you run this code again, you won't get different results. Okay. So now let's run this code. Okay, now we have run this code. So we know that this class set. So we know that this class set is white train. Okay, so white train class set. Let's flatten the array. So let's see the class set. So this is looking like a data frame. Let's do flatten. So we have a label function array v eval. So class set dot label we have. Okay, so we have flatten maybe. So flatten we have LTTEN. Okay. So what's the data frame? So what we can do is that we need to flatten the array, that is class set. So class set, we know the values of this class set. Dot values we will do. Dot values. So we have this array. Okay. This is looking like a two-dimensional array. So you have to convert it to one-dimensional array. Let's do flatten. Flatten is done. So this is the values. So the values that we have after flattening the array. The thing is that class set we have taken, and it comes out to be like we have 569 rows, right? So actually this is fine, but the thing is that we have to do flattening for test class set as well. So class test set of values that flatten we have done. Let's do test class set flatten as well. So we can use label function. We can pass values dot label. This also is used for flattening the array. This is another function dot travel, which is used for flattening the array. Let's check till here. So what is the values gives? This gives two-dimensional array. Okay. So now when you run this code, this will when you pass level function, this will flatten the array and you will get one-dimensional array. So now what you have to do is that, so let's instantiate the random forest classifier. So fit, so let's call that variable name as fit random forest. So fit random forest is equal to random forest classifier. Okay, so we have instantiated random forest classifier. So now let's call this with the main heading. Okay, so model building random forest classifier model. So we have instantiated random forest classified to variable fit underscore rf. So now let's do the hyperparameter optimization. So let's do hyper parameter optimization using search CV. So let's run this code. So now let's do the optimization. So we are using hyperparameter tuning. For hyperparameter tuning, we are using grid search CV. Grid search CV is used for select model selection, access a model selection package.